In this problem, we're given the graph of a DTDS to start with, and from that graph, they want us to choose from the list of graphs over here the solution graph to the given DTDS. So in order to do this, what we really need to do is just pull a couple of points off of our DTDS and convert them into the same values except on a solution equation. So when I do this, I'm really grabbing off sort of m sub t values, my x values, and then getting out the y value that goes with it. So when I start off and I have m0, that would be my initial value. My initial value is wherever I start on the x-axis here. So our initial condition in this situation would be 5. So that's my first x value that I'm plugging in. And from there, I use that to then draw up and hit right here on the graph. And that's basically telling me that I've got the next value, the y value that I'm plugging in would be 7. So when I plug in 5, I get 7. So then that 7 then becomes the next value that I'm going to plug into my graph. And so what you can see from there is that they end up following this point to the right. This is their cobwebbing. And then that point from there I draw up, and this is going to tell me what my next value is. So when I plug in 7, I get out the value of 11. And again, I just sort of keep following this process. When I go here, so I would go up, and from there when I plug in 11, I'm going to get out something close to 19 on the y scale at that point in time. And so as I look through here, these are some points, and using these points I can go find my graph of my solution. And all I need to do is just translate those points from the DTDS language into the solution language. And so what that becomes is the little sub-t's, the subscripts down here on these problems. So in this situation, that first one's 0, and then 1, and then 2. Those really become my t values now. So at t equals 0, I have a value of 5. At t equals 1, m sub 1, I have a value of 7. At t equals 2, I have a value of 11. And so these are now points on my actual solution graph. So I want to go find the graph that has those points. So I'd go looking for the first point, 0, 5. And you can see that that would actually be enough to get you what you need, since the first graph at 0 definitely doesn't hit at 5. And then if I look at this graph B here at 0, I draw up, and sure enough, there's a point sitting right there at 5. And if I looked and tried to do the next point, 1 comma 7, sure enough at 1, I draw up, and I can see that I've got a point here sitting at basically 7. And that continues on at 2. I have the point 11. And so I can see clearly that graph B is what I'm looking at, but you can check graph C as well, and you can see at 0 here, I definitely am missing a value at 5. I don't even have my initial value. So all you really needed to find was this first one. Would have been enough to find it on this test, but if you needed to, you would just find the graph that had all of these points on it, and that would tell you which solution graph you're looking for. So again, we start over here. Sort of step 1 of the process is grab the points off of the DTDS. Our initial condition was 5, so we plugged that in and we got out 7 on our y-axis here. Then we plugged that in and we got out 11, and then we plugged that in and we got out 19. And so once you have those points, you can then use the subscripts here as the t values or your x values in your solution, and the m sub t values become the still same m sub t values or your y values over in your solution equation.